Fractions can be represented in two different ways. One way is as a proper fraction, the other way is an improper fraction. And what that means is proper fractions have a smaller top number over a bigger denominator, a bigger bottom number. An improper number has a bigger numerator than it does a denominator over a smaller denominator. I like to call them top-heavy because the top number is bigger than the bottom number. And you can see that on the number line. From 0 to 1, that's where all of our fractions are because that's part of a whole. That's part of 1. Once we pass 1, then we have more pieces than we do with the total 1 unit. So then we're top-heavy, like the number 5/4. 5/4 would fit into this range. 1/2 is going to be right here. The top number is smaller than the bottom number, whereas in 5/4, the improper fraction, the top number is bigger than the bottom number. So this number is improper, and 1/2 is proper. Okay. We're going to use those two representations to represent the figures here. If we look at the first one, the first two entire circles are filled in. They're shaded. So when we're writing them as a proper fraction, it's actually going to be written as what we call a mixed number, because the top number has to be smaller than the bottom number in that fractional part. And a mixed number has both whole numbers and a fractional part. So when we look at number 1, we have 2 whole circles, so that would be 2 for a whole number. And then when we look at our fractional part to fill in this portion, we've got 1 shaded piece out of 4 total, so it's 1/4. 2 and 1/4 would be our proper fraction, or what we would call a mixed number, because we have a whole number there. The other way to write this would be as an improper fraction. And improper fractions are all about the small pieces. We want to know how many total pieces there are. So when we're talking about that denominator, it's how many pieces are there in one of these figures. Well, one figure has 1, 2, 3, 4 pieces, so it's out of 4. Okay, because 4 pieces will fill a circle. Okay, so we want to know in the denominator how many pieces to fill a circle. Okay, if we look at these two, if they were split up just like the third one was, we would just have 4 out of the 4, because all of them are shaded. Same thing with the first one. We would have, again, 4 out of 4. So we would have 4 here, another 4 here, so 8 total, plus 1 more. So we would have 9 pieces total. The total pieces in all over the number that it takes to complete a circle. In this case, only 4 of them, so that would be 9/4. These two fractions are talking about the same representation. If we look at the orange ones now, we can do the exact same process. Our mixed number is going to be 1, 2, 3, because we have 3 complete circles. And then when we look in the next one, it's not full, so that's going to be a fraction, because only part of it is shaded. And we have 1, 2, 3, 4, 5 pieces shaded out of 6 total. So 3 and 5, 6 is our mixed number, or our proper fraction. If we want to write it as an improper fraction, again, the denominator is talking about just one circle. And in one circle, there are 6 pieces. 6 pieces fill that circle. The numerator is saying how many total pieces we have. Because we have more than just one completed circle, it's going to be a bigger number in the numerator than we do have in the denominator. That's why we have more than one circles. So in this case, we would have 6 here, 6 here, and 6 here. That gives us 18, plus 19, 20, 21, 22, 23. So we know that we have 23 total pieces, and it's top heavy because we have more than just one circle. So that's another way. If we look at the dark green, the mixed number, we have one entire circle, and the fractional part is 1 out of 6. So that would be our mixed number. The denominator, you'll notice, has always stayed the same in our fractional part, because that's talking about just one circle. So in this case, for improper fraction, it's still going to remain 6. And then the total number of green shaded pieces is 1, 2, 3, 4, 5, 6, 7. So that would be 7, 6. These two are equivalent. Even if they aren't organized together in the same space, we can still write them as a mixed number or proper fraction and an improper fraction. If we start with that mixed number, we have 1, 2 complete circles. So our whole number is 2 because we have 2 whole circles. And then our fractional part is talking about just this. Within this fraction, we have 1, 2, 3 shaded pieces out of 8 total pieces. So this would be our mixed number. Again, our denominator stays the same. We have 8 pieces here, 8 pieces here, and 3 more. 8 and 8 is 16, plus 3 more is 19. So 19/8 is going to be our improper fraction. Even if they weren't shaded in, we could still do the same process. In this first one, we have an entire circle. So we have one full circle, and then we have half of the next circle, because if we were to complete it, we would only need one more piece. So we have one piece out of the 2 necessary, so that would be 1.5. When we're talking improper fractions, we're going to add up all of the total pieces, 1, 2, 3 pieces, and the denominator is talking about just one. In one of those circles, it was split into 2 pieces, so 2 is our denominator. They are equivalent. In this next one, for the mixed number, we have 1, 2, 3 complete circles, and then half of the next one, so it's 3.5. If we were to write that as an improper fraction, we would have 1, 2, 3, 4, 5, 6, 7 pieces, and in one circle, there are only 2 pieces, so it would be over 2. Again, an improper fraction must be top heavy. If we look at triangles instead, it's still the same idea. This one is a completed image because we started building on another one. So we have one full figure, one complete figure, and then one piece in the next one. So it's one piece, but then we have to determine how many pieces will create a whole one. 1, 2, 3, 4 pieces. So it's 1 out of 4 for this next figure. If we were to count them all as pieces, the denominator stays the same because 4 pieces will create a whole image, and then we have 1, 2, 3, 4, 5. So then 5/4 would be our improper fraction. It's top heavy because we have more pieces than just completing one figure. Just like up here, we had 3 figures and then a little bit more. So our top number is top heavy because we have more than just one complete figure. What we'll have to be working on is being able to convert a mixed number to an improper fraction. And this is where we're dancing. When we convert mixed numbers to improper fractions, we do what's called the boom boom dance. And when we do the boom boom dance, we're going to talk about this fraction in terms of the words that typically 7th graders are using. The numerator, a lot of students like to call this the top number. The 4 is in the denominator, but a lot of 7th graders like to call that the bottom number. So when we're trying to convert a mixed number to an improper fraction, just like we were working with before, there's a connection between them. The denominator is telling us, well, how many pieces are in one full unit? So in this case, there are 4 pieces that create one whole. Okay? There are 2 whole figures. So between these two, we have 4 pieces and 1. So it's like we have 4 pieces here. 1, 2, 3, 4 pieces in that one. We have another 4 in this one. 1, 2, 3, 4. And then we have 1/4 of the next one. So if we're just talking about these 2 whole pieces, what we're doing is we're taking 2 times 4, which is going to give us 8. 8 pieces from that. Then we're going to add this leftover piece. There's 1 piece there, and that's going to give us 9. What you see here is we're taking the bottom number times the side number to get 8, add the top, boom, boom. Our denominator will always stay the same, so our denominator stays 4. And when we're doing the bottom times the side to get our 8, adding the top, that's counting up how many pieces we had. Well, the total number of pieces goes in the numerator, so we have 9 total pieces. So for this example, our new improper fraction is 9/4. We want that top number to be bigger than the bottom number because we have more than 1 full unit. We have 2 and 1/4. So we did bottom times the side. 4 times 2 is 8. Add the top, gives us 9, and then it's 9/4. Denominator stays the same. Let's practice this a few times. So for this one, if we do bottom times the side, that's going to give us 12. Add the top, that's going to give us 13. Notice we ended in the top, and the denominator always stays the same, 13/12. Bottom times the side, add the top, boom, boom. Let's do the next one. Bottom times the side, 2 times 4 gives us 8. Add the top, gives us 11. Denominator stays the same. Bottom times the side, add the top, boom, boom. Let's do the next one. Bottom times the side, 2 times 8 is 16. Add the top, gives us 17. Denominator stays the same. Bottom times the side, add the top, boom, boom. Next one, 4 times 5, that gives us 20. Add that top number, 3, that gives us 23. Denominator stays the same. Bottom times the side, add the top, boom, boom. Number 8, 3 times 5, bottom times the side, that's 15. Add the top, that gives us 16. And the denominator stays the same. Boom, boom. Bottom times the side, add the top, boom, boom. Last one. Even when we have more challenging numbers to multiply, the process is still the same. Bottom times the side, so 9 times 7 is 63. Add that top number, 63 plus 8 gives us 71. Denominator stays the same. Bottom times the side, add the top, boom, boom. And that's how we change an improper fraction, or that's how we go from, that's how we convert a mixed number to an improper fraction. The boom, boom dance. Other times, rather than working with improper fractions, we want it to be a mixed number. So we're going to use this symbol within our fraction to create that mixed number. Not only is this a fraction symbol, but it also means to divide. So we're going to divide 13 by 4. The little phrase I use to remember that is topsy in the boxy. Topsy in the boxy. The 13 is in the top, so that's going to go inside our division box. Topsy in the boxy. And then we're just going to divide. 4, we cannot take 4 from 1. There's not enough. But 4 can go into 13, or we can take 4 from 13. And we can do that 3 times, because 3 times 4 is 12. And when we subtract, we've gone all the way to the end of our number, and we have 1 left over. So it worked 3 full times, so that's the whole number, with 1 left over piece. Meaning that we have 3 as our whole number, 1 left over, which means 1 goes in the numerator, and the denominator always stays the same. The denominator always stays the same. So let's do a few more practices with that. Okay. Again, this is a division symbol, so we're going to be doing topsy in the boxy. 7 divided by 3. We can get 3 from 7 2 times. We want to double check it. 2 times 3 is 6. We have 1 left over. 2 is our whole number. 1 is left over. It was extra, so we have 2 and 1 piece, so 1 goes in the numerator, and the denominator always stays the same. So for this next one, topsy in the boxy, 36 divided by 7. We can't get 7 from 3. It's not enough. So we put an X there because we want to keep everything nice in a line. 7 can come from 36. 7 times 5 is 35. This is where our multiplication facts are really helpful. And we have 1 left over. So we have 5 as our whole number, 1 piece left over, so it goes in the numerator, and the denominator stays the same. Same thing here, topsy in the boxy, 44 divided by 10. 10 does not go into 4. We cannot get 10 from 4, but it goes into 44 4 times, because 4 times 10 is 40. This time we have 4 left over. This 4 is our whole number. This 4 is left over. They were extra, so we have 4 out of, the denominator stays the same. You'll notice for this fraction that our fractional part needs to be simplified because they both are even numbers. We can divide both of those numbers by 2. So we're going to show that process, keeping in mind that the whole number is still there. We still have 4 whole pieces. We're just simplifying that little fraction to create an equivalent fraction of 2/5 for our final answer. Topsy in the boxy, 44 divided by 6. It doesn't go into 4, but it goes into 44 7 times. 7 times 6 is 42, with 2 left over. What would that mixed number look like? 7 and 2, 6. The denominator stays the same. Again, 2 even numbers, so we would have to simplify both of them by dividing by 2, giving us 7 and 1/3 instead as our final answer. For number 11, topsy in the boxy, 11 divided by 2. It doesn't go into 1, but it goes into 11 5 times, which gives us 10. 5 times 2 is 10, 1 left over. 5 and 1/2 as our answer. The last question, 18 divided by 7, topsy in the boxy. 7 goes into 18 2 times. 2 times 7 is 14, so we have 4 left over. 2 is our whole number because I worked 2 complete times. And 4 out of 7, the denominator remains the same. So to recap, when we are going from a mixed number to an improper fraction, we're doing the boom boom dance. Bottom times the side, add the top, boom, boom, denominator stays the same. When we're going from an improper fraction to a mixed number, we're just dividing topsy in the boxy, and then writing what we have as a leftover piece. The denominator, once again, stays the same.